This lesson is about dilations. We're going to learn how to dilate figures when the center of dilation is the origin. So the title of my lesson is going to be Dilations with the origin as the center. And I'll start with the definition of dilation is the process of making a figure bigger or smaller. Okay, it's one of the different types of transformations that we study, along with translations, reflections, and rotations. A scale factor is the ratio of any two corresponding lengths in two similar geometric figures. This is a really fancy definition, so I'm going to give you a more simplistic one, which is the number that you multiply by. So if you can remember that the scale factor is the number you multiply by, you will be in pretty good shape. We're going to start with example 1. Example 1 says, graph the dilation. The center of dilation is 0, 0. The scale factor is 2. So we're going to start with A, B, and C, and we're going to plot those points. A is 0, 2. B is 2, negative 1. And C is negative 1, negative 2. So go ahead and graph 0, 2, label it A. 2, negative 1, label that B. And negative 1, negative 2, and put a label on that and call it C. Now the scale factor tells you how much bigger or smaller the figure is going to be. So a scale factor of 2 tells you the image, so here's the pre-image, the image over here is going to be twice, 2 times the size of this figure. So it's going to look like that. So all that I need to do, because this is super important, because the center of dilation is 0, 0, I have an easy way of dilating this figure. You are going to multiply by 2. You're going to multiply everything by 2. So A prime will be, take 0, multiply it by 2, and you get 0. Take 2, multiply that by 2, and you get 4. Take 2, multiply that by 2, and you get 4. Negative 1 times 2 is negative 2. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. That is all that you need to do. And now we're going to graph it. 0, 4 is A prime. 4, negative 2 is B prime. And negative 2, negative 4 is C prime. So we have dilated the figure. Okay, let's go ahead and fill in the blanks. The blanks say an enlargement makes the figure larger, makes a figure larger. The scale factor for an enlargement is, we use the letter K for scale factor. K is greater than 1. So K is a number larger than 1 when the figure gets larger, which means that it is greater than 1. A reduction makes a figure smaller. The scale factor for a reduction is K is in between 0 and 1. Which means that it is between 0 and 1, such as, what if K was 1/4? That means that your figure would be 1/4 the size that it started as. So let's go ahead and answer these questions down here. They're pretty simple. Is this an enlargement, a reduction, or a congruence? So if K is 1/2, has the figure gotten larger or smaller? It's got smaller, so this is a reduction. What about K is equal to 6? That's an enlargement. What about K is equal to 3/4? That means it's smaller. That's a reduction. 75% of what you started with. And the last one is 5/4. This is an enlargement. 5/4, if I could spell, enlargement. 5/4 is the same as 1 and 1/4. That's larger than 1 because the numerator is larger than the denominator. So that's an enlargement. Okay. We have a few more examples. We have 2 more examples and then some practice questions to answer. So example 6 says graph the dilation. The center is 0, 0. The scale factor is 1/4. We're going to have to be doing some a little bit of extra math. We might want to use a calculator for this. We might not. I'm going to give you T, U, and V. Those points are 4, 8, -5, 7, -8, 1. Okay, so let's go ahead and graph them. 4, 8, -5, 7, and -8, 1. Okay, so I have a triangle and it is going to get smaller because this is a reduction. Everything is going to be 1/4 the size that we started. So you can either multiply by 1/4 or you can divide by 4. It's the same thing. So how about we just think of this as dividing by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. -5 divided by 4 is -5/4. 7 divided by 4 is 7/4. Okay, so if we would like to write that in a nicer way, we could say this is -1/4, -1 1/4, and we can say that this is, it's almost 2, because 8 divided by 4 is 2. So this would be 1 3/4. We're missing that 4th to get to 2. This is not really changing again. I'm going to say it's u prime, aka u prime is also this. V prime, the last one, -8 divided by 4 is -2. 1 divided by 4 is 1/4. Okay, so go ahead and graph 1, 2. And then we're going to graph -1 and 1/4, comma, 1 3/4. It's right here. And then we're also going to graph -2, comma, 1/4 is right there. Okay, so it's a little harder to do because it's so tiny, but we have a triangle that looks like this. Okay, all right. Let's go on. The last example says the center of dilation is 0, 0. Determine the scale factor. So there's a few ways you can do this, but what I'm going to do, since the center of dilation is 0, 0, I'm going to do this the easiest way that I know how. Okay, so choose 2 points that are corresponding points. I'll choose A and A prime. A is located at 9, 9. And somehow it was transformed to get A prime 3, 1, 2, 3, 3, 3. Okay, so somehow I got from 9, 9 to 3, 3. What do you multiply or divide by to get from 9 to 3? That's dividing by 3, which is the same as multiplying by a third. So your scale factor is 1/3. Okay, so K is equal to 1/3 would be the fancy way of writing it. All right, all that we have left is a couple of practice examples. So let us take a look at those 2 examples. This would be a good opportunity for you to pause the video and try these on your own. Practice 1 says dilate the figure using a scale factor of 1/4 and the center of dilation of 0, 0. Okay, so what I would like to do for this is I would like to write down what these coordinates are. I think it's the easiest way. So W is located at 0, 4, and if I use a scale factor of a fourth, remember I either multiply by a fourth or divide by 4. So to get W prime, 0 divided by 4 is just 0. 4 divided by 4 is 1. So W prime is located at 0, 1. Okay, how about X? X is located at 4, 4. If I divide each of those by 4, this should be an X, not a W. X prime will be 1, 1. Okay, and then I have Z and V. Z is located at 2, 2. If I divide both of those by 4, I get 1 half, 1 half. So it's a little hard to do, 1 half, 1 half. It's a little bit small here. And then the last one is V. V is negative 2, 2. It's very similar. So V prime will be negative 1 half, negative 1 half. Negative 2 divided by 4 is negative 1 half. So negative 1 half. Ooh, I better correct that. Negative 2, positive 2 was V. So this should be negative 1 half, positive 1 half. Negative 1 half, positive 1 half. That looks better. Okay. Alright, so you should have a cute little figure like that. And this is the final example. The center of dilation is the origin. Determine the scale factor. So one thing that I could do, since the center of dilation is the origin, is I could compare two corresponding vertices, C and C prime. C is located at negative 10, 5, and C prime is located at negative 2, 1. So you're going to ask yourself, how do I get from negative 10 to negative 2? What do I multiply or divide by? I know I divide by 5 to get from 5 to 1. That is the same as multiplying by 1/5. So the scale factor is 1/5 for this question. Thank you so much for watching.